Første foredrag nå etter pausen av forskningssjef og en av grunnleggerne av NOMI, som Norwegian Mycelium, David Andrew Quist. Quist blant annet skaperen av den prisbelønte restauranten Rimnir Ramen. Og i dag skal han holde et foredrag for oss som heter Mycelium Rising Sopp for en bærekraftig framtid. NOMI produserer blant annet mycelium som brukes til mat, og brukes i materialer som lyddempende. Og dette i et samarbeid med Snøhetta. Velkommen til studio, David.
Tusen takk.
Mens du står her.
Ja.
Takk for at du kunne komme hit og holde foredrag for oss.
Ja, takk for invitasjonen og komme og prate om sopp.
Ja.
Alltid artig.
Vær så god, ordet ditt.
Takk skal du ha. Yes, som nevnt David Andrew Quist. Jeg soppforsker. Jeg forskningssjef til Norwegian Mycelium, som nevnt. Og hva det kommer til å dele med dette om sopp og framtiden. Så hovedbudskapet så lenge at like viktig som sopp har vært på historien, på livet på landet, skal det være viktig for framtiden, et bærekraftig framtiden. Så jeg skal dele litt om meg. Jeg skal snakke og presentere 5 forskjellige soppløsninger for en bærekraftig framtiden. Vi skal snakke litt om industrialisering av disse løsninger her i Norge. Vi skal snakke litt om kunnskap, om kompetanse og nysgjerrighet, og ta spørsmål og svar til slutt. Jeg tenkte jeg skal kjøre en del av foredraget på engelsk. En av mine beste venn Hanne sier, David, du enda mer skjermende på engelsk enn du på norsk. Så jeg skal kjøre litt på engelsk, men vi kan ta spørsmål og svar på engelsk eller norsk etterpå. So a little bit background on me. So I wasn't always interested in mushrooms, to be honest. Grunge music, that was my thing, way back in the day in the 1990s. So I was living in Kansas City, where I grew up in the middle of the United States. And I decided to move to Seattle, Washington, which is like the mecca of grunge music in the 1990s. So I loaded up my pickup truck and I moved to Seattle. And I wanted to play grunge music. And while the magic of Nirvana and Pearl Jam didn't quite rub off on me, the forests of the Pacific Northwest did. The way that the forest ecosystem, the fungi, the animals, the plants, all of it really captured my imagination. So I stopped playing music and I enrolled at the University of Washington in Seattle to study about forest ecology. And quickly I got turned on to the magic of the microbial world, particularly of fungi, and how life's history, everything around us that we come and know, has a fungal backstory. All where we go is because of fungi. And I wanted to explore that further. So I did a master's thesis in mycorrhizae to learn more about these symbiotic relationships between plants and animals, or plants and fungi. I went on to the University of Chicago and the Field Museum of Natural History, where I spent 1.5 years traveling the globe in research projects, picking fungi, spending all day picking fungi and all night describing them, like #dream job, right? So I did that for 1.5 years, but I wanted to get back in really studying and advancing my knowledge on fungi. So I went to the University of California, Berkeley, to study about mushrooms. So I was based in Mexico and doing projects related to ectomycorrhizal fungi in the forests of Mexico. After I finished my PhD in California, I landed in Tromsø. Kind of a change going from California to the Arctic Circle, I must say. But it was an amazing opportunity to explore a little bit different fields about technology and its role in society. So we were doing lab research, being a part of the debates about new technologies like genetic engineering and nanotechnology, and how they're used in society and who decides. So I was doing a lot of technical advising on these issues for the Norwegian government. I spent some time as Norwegian representative in the United Nations on ecological monitoring of new technologies on committees of the conventional biological diversity. I then went to Copenhagen to lead a program on sustainable food systems for the European Environment Agency based in Copenhagen. But I was getting really far away from my first love, which was science and microorganisms, particularly fungi, and wanting to create impact. So I took a break. I started, wanting to create with fungi. And what more fun thing to create with fungi than food, as we all know. And so I started developing concepts using fermentation to tell stories about food with fungi and microbes, and ended up opening my own restaurant called Rimnir Ramen. It's based in Oslo, in the Vulcan area, where we tell stories about fermentation and local food production through a delicious, messy bowl of noodles. Maybe some of you have been there, but it's a really great neighborhood place if you ever want to try it. Currently, I am the research chef of Norwegian Mycelium. As mentioned, we're a small startup company that is researching and innovating new products in new areas and how we could use fungi to create sustainable solutions for the future. And it's really that passion to see how we can create impact from the microbial world that we started Norwegian Mycelium. Now, as we all know, we're facing a lot of sustainability challenges the whole world over. Two that I'll mention is plastic use, right? It's a fantastic material, but it doesn't break down easily. And we have this system, this linear system of how we use things, where plastic is essentially polluting the earth. It's estimated that at current rates of consumption in the oceans, by 2050, there will be more plastic than fish. We need to do something about this. The other area isn't about food and feed, right? If we're going to be a thriving planet of 10 billion people by 2050, where are we going to get the food that we need to feed the population? Current methods of production, if you do the math, it doesn't add up. We need more sustainable ways of producing and consuming food. So I'm going to present to you 5 solutions that I think are going to be part of the future, coming from the fungal world, to be able to address some of these urgent problems. The first one is in material science. And some of the species that's being worked with, you see in a list here, Ganoderma, Pleurotus, and Trametes, to be able to create new structures from fungi that can be solutions to new product areas. So one that my company is working on in conjunction with Snøhetta is about new building materials that are lower in CO2, can replace unsustainable things like rock wool or styrofoam, isopor, and be able to have more greener buildings. So if you could run the video, this is a little intro into our work with Snøhetta.
So it all started when Snøhetta approached our startup, Nomi. We're a company that's making new products from the root-like structure of fungi called Mycelium. And asked the question, what if we could create a building material that didn't just take from nature, but gave back to it? Could we tap into the biointelligence of the fungal world and do things better? Using a forest fungus and waste products from agriculture, paper production, things like leftovers from wool and dairy whey, we literally grew a soundproofing material that is naturally fire resistant, produces no volatile chemicals, and is 100% compostable in nature. When Snøhetta designed the new offices of Sally for EY Doberman, that's really where our collaboration began in earnest. To create a material that performed industry standards, but gave an aesthetic that inspired curiosity and perhaps awe for the natural world. For me, fungi are amazing because they teach us how all of life is interdependent. That collaboration and working together is truly where innovation thrives. That they can help us think differently as we collectively create a better future. To go beyond just being sustainable and be regenerative. To not just be net zero, but net positive in our impact on the world.
So yeah, in this video, I see that video and I realize, man, how scruffy I was getting, right? I mean, I'd spend weeks in the forest looking for the perfect Ganoderma lucidum for our project. And as you saw it growing on that log in a forest in Vestfold outside of Sogndal, I found it. Other solutions, aside from building materials, using material science, is in the production of new types of packaging material that can replace styrofoam. So instead of getting your makeup or your wine bottle or your computer in styrofoam, isopod, you might in the future be able to get it in mushroom packaging that is completely decomposable in nature. You can break it up, put it in your compost, feed it to your cow. It will just basically disintegrate back to the microbial world in a short time. Another really cool area that we're innovating is in mycelium-based leathers, mushroom leathers, as you see here. I mean, think about how leather is produced today. You have to raise a cow, feed the cow, slaughter the cow, give it antibiotics, transport it, tan it, do all these things to make it into a leather product. It's about a 3-year process. With mycelium, we can grow mycelium and produce a mycelium-like leather that has the same texture and feel and durability as leather in 6 days, right? Isn't this a more sustainable way that we could produce that can basically avoid all of that long chain, that 3 years to make it from cows? I think it's a more sustainable way. And you're seeing the likes of Adidas and Mercedes-Benz, Volkswagen, Stella McCartney, investing into mycelium leathers to create handbags and car interiors and shoes. Another solution is in food and feed that I'm very passionate about, and using microbes to be able to produce so-called plant-based or fungus-based alternatives to meat. So in the same way, the actual producing of meat is a long value chain. It uses a lot of resources to actually make a kilo of animal-based protein. But using fungi, we can do it much more effectively at very large scales. But it's not doing what's already in the industry now, which is like burgers and meatballs that are plant-based products that are pressed together with chemicals. But we can actually make a whole-cut product using the natural advantages of mycelium and a hyphae. So if you think of a hyphal strand, a strand of mycelium, it's about the same width as a muscle fiber. And if we can orient those fibers in such a way, we can create a muscle-like texture in our food products to give that whole-cut, craveable experience that meat eaters really want to have. And flavor it the right way, we can make it just as delicious or more delicious than the real thing. And this is something that I'm working on to introduce in my restaurant, hopefully later this year. Another area is in feed. Here in Norway, of course, we are a salmon nation. Currently, we're importing up to 1 million tons of soy per year to feed our fish. And we all know that soy is contributing to land degradation and deforestation, where we get it in Brazil. And it's also taking away from land that might be used to be able to make feed for humans in places where they really need food. Can't there be a more sustainable way in which we can produce these proteins that we would need to feed to our fish? It just isn't sustainable to continue to use soy. And given that the industry wants to grow 2 to 3 times in the coming years, we need to find alternatives that are more sustainable. And fungi can be part of this solution. So fungi, as you know, evolutionarily are more closely related to animals than they are to plants. And so their proteins are very much like animals in that they have all the amino acids that are needed for good growth. And so we can produce a high-quality protein in very large scales to meet the needs of the salmon industry in the future. Here are some of the species that are being worked with. You can see Pleurotus, the oyster mushroom is one. Aspergillus, also known as the koji mold, which is used to make things like miso and soy sauce. Rhizopus oryzae, which is used in tempeh production. And other very fast-growing fungi that can essentially double its mass in about 8 hours. So if we're growing it in tanks of hundreds of thousands of liters and doubling that biomass every 8 hours, we can create an incredible amount of proteins in a very short time. Some of these species also are very high in the actual percentages of proteins that they actually produce, like Neurospora, up to 60% of its biomass is proteins. So we think this is going to be an important solution, particularly in Norway in the future. Improving soil health is another area that is going to be really important in the future. You know, we've spent decades depleting our soils by an overuse of synthetic chemicals that has really impacted the microbial diversity of our agricultural systems. And now using AM fungi, mycorrhizal fungi, and we're able to make these soils better. Now, I know Andy Taylor's going to be talking a little bit about regeneration of forest ecosystems with mycorrhizal fungi, and he'll be able to cover this in much more detail and a better job than I can. But just to give you an overview, you know, we can improve soil health, we can improve the ability of the plants to be able to thwart off pathogens, be able to take in elements like phosphorus in a more efficient way. That's going to mean for a more healthy plant and more productivity that we're going to need to meet the needs going further. Another area is in mycoremediation, this idea of using fungi to be able to help clean up contaminated areas from oil or other kinds of impurities like heavy metals or chemicals. And sometimes we don't know or forget that, you know, fungi, particularly some species like Trichoderma, Pleurotus, and Aspergillus, have an amazing array of enzymes that they can produce to break down things in nature. So typically, you know, like Pleurotus is really good at breaking down wood of this hemicellulose and cellulosic material. And when it encounters that wood in nature, it turns on and is stimulated to turn on the enzymes that can break down whatever it finds in nature. And it's the same thing if, say, Pleurotus is to encounter a large hydrocarbon molecule like oil. That library of enzymes gets turned on to be able to degrade and use it as a food source. So using fungi to be able to basically regenerate soils, that regenerative capacity of fungi coming again to be able to create more healthy environments. And we're talking about solutions here on little Earth. But what about in space? I'm not sure if you thought we'd be talking about space fungus, but now we are. In NASA, they've had a program for some time to look at how fungi might be able to be used for solutions in space. Now, I don't know if you've thought much about living in space, but there's a couple of really key problems. One of them is gravity, of course. Another is radiation, gamma radiation from outer space that you would be bombarded with is very unhealthy for our cells. And so coming up ways to protect us from all that radiation is very important. And that's one thing where fungi also excel. It has a natural ability to absorb or repel radiation like gamma radiation, which would be harmful to humans living in space. So NASA has had a program to be able to grow using fungi like Pleurotus and Ganoderma to be able to grow habitation for humans that would be on the moon or in the International Space Station. Another problem, you know, is resources, what you have. You can't just run down to the Narvesen and pick up something you forgot, right? If you don't have it on the space station, you can't, you're not in a good place. And so what if we could have fungi to be able to use resources there, to be able to create whatever you need on demand? Like if we use Aspergillus to make some food, or be able to make a new chemical that we need, like an organic acid or a preservative, or be able to grow antibiotics on demand using a catalog of fungi in mini bioreactors. So we've been talking to the Norwegian Space Agency, Norsk Center. Yes, Norway actually has a space program in these kinds of solutions that might be able to be used as we continue to explore space. But how are we going to develop these technologies, these great solutions, right? I mean, it's one thing to develop a sustainable solution, but you need to be able to produce it also in a sustainable way. And here's again where we can tap into the natural abilities of fungi, the versatility of fungi to utilize a whole range of different underutilized biomasses as food, so-called feedstocks, in the production of these solutions. So these are things that we have in abundance here in Norway, like wood, seaweeds, and various side streams from different process industries like beer and wastewater from beer. That is actually a very nutrient for fungi. Another example is whey, mysa, from the dairy industry. 9 kilos of whey are produced, mysa, for every kilo of cheese produced. That's a massive amount of waste products. That's just food for fungi. So we're investigating ways in which we can use things like mysa to be able to make a fermentation system to grow fungi to create high-value products, the ones that I talked about. So that's how we can be circular and sustainable in our production. We can scale it up, as that's one of the other advantages of fungi is they're self-replicating, so we can grow big masses on large scales to truly be disruptive if we're going to change to more sustainable systems. So, driving this new company, Norwegian Mycelium, I talk to a lot of investors that are interested in investing in us, and they always ask me, what are your bottlenecks? Is it money? Is it the technology? What is going to help you grow? And the answer, probably the biggest answer for myself is knowledge and competence. Fungi grow on trees, but fungal researchers don't grow on trees. Where are the next Håvard Kosruds going to come from, right? We actually are not developing this capacity to be able to develop an industry based on microbes here in Norway, particularly fungi, for solutions that we need for the future. So if there's one thing you can do, it's to educate and create curiosity in young people about the microbial world, not just in the fungi that you can pick and eat, but how they're connected to life all around us and how they can be important for their future. And maybe this is, I don't know who this is in the picture. It kind of looks like it might be Håvard's son. I don't know. But we need to educate our youngsters, get them interested in the microbial world to be the researchers we're going to need for sustainable products in the future. Thank you very much.
Hvorfor velge Geoderma lucidium? Hva med for eksempel Geoderma applanatum?
Ja, det forskjellig. Vi kunne ha brukt noe annet. Det var spørsmål om hvilke funnet i naturen som vokser best i våre hånder. Men det var det Ganoderma lucidum. De som har også, hvis du sa i den platene, de har liksom orangefargen, og vi vil ha den naturlige fargen for Ganoderma lucidum, for å skape en estetisk typ på platene vi har skapt for snøhette. Så det har vi testet forskjellig, med de som vokser best var faktisk Ganoderma lucidum, som også har den aesthetic effekt som vi ønsker.
Ja, det så jo unektelig kult ut med fargenyansene og mønstrene på det.
Ja.
Og jeg tenkte jo litt på å bruke sopp som isolasjon. De fleste av oss jo redd for å få sopp i husene våre, fordi at det tyder jo gjerne på råteskade og sånt. Er de herrene platen behandlet på noen måte sånn at soppen er død? At det dersom det kommer fukt til, at ikke dette våkner til livet og begynner å bryte ned videre?
Ja. Det veldig godt spørsmål. Ofte når vi snakker med arkitektene, de sier vi bruker så mye tid at vi unngår å ha sopp i bygningen, og nå du vil ha at vi intensjonelt tar sopp i bygningen. Men nei, som du sa, hva vi gjør, og når du sa den platen som vi skapte i videoen, da vil vi tørre den ut. Og da det blir, hvis vi bare tørrer den ut, det kan vokse igjen hvis det blir fruktig nok. Men det det pur mycel, det ikke noen sporer, ikke noen sopp som vokser. Men vi tar temperaturen, vi som koker platene over 60 grader, da det blir helt tørt og helt død. Så det kan ikke vokse videre.
Og du har jo brukt mycelium for å lage mat, rett og slett. Hvordan smaker egentlig dette myceliet? I forhold til for eksempel, forskjellige fruktlegmer har jo forskjellig smak. Er myceliet også sånn at det smaker som fruktlegman da?
Det et veldig godt spørsmål. Det vi driver med mest nå veldig neutralt smak som ostersopp. Da det litt lettere å ta forskjellig hvis vi skal lage noen svinn, like pork cutlet, eller kylling, eller buff, så vi kan tilsette smaken vi ønsker. Men man kan også tenke å bruke chicken of the woods, eller lobster mushroom, eller beefsteak mushroom, som har den naturlige smak og egenskaper på denne retning. Vi ikke starter med forske med den akkurat nå, men vi tenkte i framtiden som chicken of the woods sopp, som allerede har litt den essensen av kylling, kan være nyttig.
Ja, veldig spennende. Du hadde jo også noe om microremediation, det å bruke sopp til for eksempel å bryte ned oljeavfall eller lignende. Det sånn at den soppen også trygt å brukes til mat da, etter å ha brutt ned oljeprodukter?
Da må du teste, fordi også sopp kan være lett å ta opp liksom heavy metals og sånn, som blir litt farlig. Så det litt vanskelig å kombinere mat med den, men du ser noen av disse tester med det bruker ostesopp, og det kommer opp masse ostesopp, og du tenker, folk som sier, nei, men ikke spise dem. Da kan du resirkulere og bare ting som må ikke ta i bruk for humanisk konsum, men kan være en viktig løsning fremover.
Ja, det jo kjent at enkelte av soppene tar opp mye tungmetaller, og det gjelder jo blant annet for eksempel rimsopp eller blek piggsopp og enkelte sånne. De tar opp ekstra mye tungmetaller. Og så hadde du jo litt om rommet, og det å fungere som radiologisk beskyttelse. Og der vet du at de har oppdaget sopp som vekser i Tsjernobyl, i atomreaktoren der, som faktisk vekser bedre når den blir utsatt for stråling. Kjenner du til dette?
Litt. Det sikkert veldig interessant hvis du ser problemet de har på på space stations. Den russiske space station har masse problemer med Aspergillus niger, som vokser veldig godt på, det en lukket system faktisk i en space station som ganske fryktig, og de tar soppen som kommer fra kloden opp med dem, og de som vokser best Aspergillus niger, fordi de tolerer og faktisk vokser veldig godt i slik radioaktive situasjoner som dette. Så det kan også skape en problem. Det blir alt for mye fungi på Space Station, men det kan bruke noen nyttig arter på god måte.
Ja. Ok, tusen takk for presentasjonen du hadde. Det var hyggelig å ha deg.
Ja.